Ever wonder how a jet engine actually works? Picture a giant vacuum cleaner, but instead of cleaning your carpet, it's sucking in air from outside. This is how a jet engine starts its process. It pulls in a massive amount of air through its front. Now, here's the surprising part. That air doesn't just sit there, it gets compressed. Imagine squeezing a sponge filled with water. As you press it, the water is forced into a smaller space. Similarly, as the air moves through the engine, it gets squished down by powerful fans, making it super dense. This is crucial because it allows for a more efficient combustion process. Once the air is compressed, it meets fuel. Think of it as adding a splash of gasoline to a fire. The engine mixes this compressed air with the fuel and sparks it with a flame. When this mixture ignites, it creates an enormous amount of hot, expanding gas. This high-speed gas rushes out the back of the engine, pushing the aircraft forward in the opposite direction. This is called thrust. It's a bit like blowing up a balloon and letting it go. The air rushing out propels it in the other direction. So, to wrap it up, a jet engine is like a powerful vacuum cleaner that sucks in air, compresses it, mixes it with fuel, ignites that mix, and creates thrust to propel the plane forward. It's a fascinating dance of physics that keeps us flying safely through the skies. If you're curious to learn more about how planes work, make sure to subscribe. Have you ever wondered how a jet engine begins its work? First, let's look at the air intake. As the plane moves forward, it pulls in huge amounts of air through the front of the engine. Think of it like a straw sipping up your favorite drink. When you suck on a straw, you create a low-pressure area, which pulls the liquid up. In a similar way, as the aircraft speeds along the runway, it creates a low-pressure area in the front of the engine. This design is crucial. The air intake is shaped to funnel in the maximum amount of air smoothly and efficiently. Instead of chaotic airflow, the intake transforms that rushing air into a steady stream, much like how a funnel directs water into a bottle without spilling. And here's the surprising part. This airflow is vital for the jet engine's performance. Once the air enters the engine, it's not just any air. It's compressed, heated, and mixed with fuel to create a powerful explosion. More on that later. What's fascinating is how much air a jet engine can pull in. To give you an idea, a large jet engine can intake enough air to fill an entire house every few seconds. That's why engines are so powerful. They're not just relying on fuel, they're working with massive amounts of air to create thrust. So the air intake is the first step in a jet engine's operation, acting like a straw to sip in the very air that will help propel the plane into the sky. There's so much more to uncover about how all this air transforms into flight. Once the air passes through the intake, it moves into the compressor. This is where the magic of compression happens. Think of it like this. Have you ever pressed down on a sponge to squeeze out more water? That's exactly what's happening to the air in the compressor. Inside, there are a series of fan blades. They spin rapidly and squeeze the incoming air. As the blades whirl around, they compress the air, increasing its pressure and density. This is crucial, because denser air can be mixed more efficiently with fuel for combustion later on. But here's the surprising part. As the air gets compressed, it also heats up. Just like a bicycle pump gets warm when you pump it, the same principle applies here. The more you compress air, the hotter it gets. This is why jet engines are designed to handle high temperatures and pressures. When the air leaves the compressor, it's not only denser, but it's also significantly warmer. This high-pressure, high-temperature air is essential for the next stage, combustion. So to recap, the compressor takes in the air and squeezes it, making it denser and hotter, preparing it perfectly for what's to come. Understanding this step helps you see how each part of a jet engine works together to create that powerful thrust that lifts us into the sky. Curious about what happens next? Stick around to learn about how this compressed air meets fuel to create the energy that powers the aircraft. Now comes the exciting part, mixing the compressed air with fuel. Think of it like lighting a campfire. You gather dry kindling, throw in some logs, and then add a spark. In a jet engine, that spark is our ignition system. Once the air is compressed, it's channeled into the combustion chamber, where fuel is injected at just the right moment. This fuel mixes with the high-pressure air, creating a combustible mixture. It's carefully calibrated. Too much fuel, and it won't burn efficiently. Too little, and you won't get the power you need. When the fuel ignites, it burns incredibly hot, reaching temperatures of up to 3,000 degrees Fahrenheit. That's hotter than a pizza oven, and enough to create a significant amount of energy. Just like that campfire, this reaction produces expanding gases. But instead of just heating up the air, These gases are forced out of the engine at high speed. Here's the surprising part. That rushing hot gas is what creates thrust. Think of it as blowing up a balloon and then letting it go. The air rushes out one end, and the balloon shoots off in the opposite direction. In our jet engine, the same principle applies. The more fuel we have burning in the combustion chamber, the more powerful the thrust we generate. This entire process happens rapidly, with the engine continuously drawing in air, mixing it with fuel, and igniting it. It's a perfectly synchronized dance that propels the aircraft forward. So to answer the question, in the combustion chamber, compressed air and fuel mix, ignite, and produce high-speed gases that create thrust, much like a campfire producing heat and energy. Stay tuned as we uncover what happens next in this power-packed journey. What happens next? The burning gases from the combustion chamber rush out of the back of the engine. Picture this like water flowing out of a faucet, only much hotter and faster. As these gases escape, they spin a turbine, much like how water spins a water wheel in a river. Now, here's the surprising part. That spinning turbine isn't just for show. It plays a crucial role. The turbine is connected to the compressor we talked about earlier. As the turbine spins, it powers the compressor, drawing in more air and repeating the whole cycle. It's like a well-oiled machine, each part working together seamlessly. But what about thrust? That's where the fast-moving gases come into play. As they shoot out the back, they create a reaction that pushes the plane forward. Think of a balloon. When you let it go, the air rushes out one way, and the balloon flies off in the opposite direction. In a jet engine, the principle is the same. The more air that rushes out, the more thrust is generated, propelling the aircraft down the runway and into the sky. This process happens incredibly fast. The engine keeps pulling in air, burning fuel, and pushing out gases, all while providing the thrust needed to lift and move the aircraft. It's a powerful, efficient system that helps keep flying one of the safest modes of travel. So in summary, the burning gases spin the turbine, which powers the compressor, and the fast-moving exhaust generates thrust to push the plane forward. Isn't that fascinating? If you're curious to learn more about how planes work, don't forget to subscribe for our next deep dive. So how does all this add up to a safe flight? Jet engines are designed with an impressive level of reliability. Think of them like a multi-layered safety net. Each engine has multiple components that work together, so if one part has an issue, there are backups ready to step in. It's like having several lifeguards at a pool. If one is busy, another is right there to keep everyone safe. Before they ever reach the skies, these engines go through rigorous testing. They're subjected to extreme conditions, high heat, low temperatures, and even simulated bird strikes. This ensures that they can withstand almost anything they might encounter during flight. The standard testing process is so thorough that it's rare for a malfunction to occur during an actual flight. In addition, regular maintenance checks are mandated for all commercial aircraft. Every single component of the engine is meticulously inspected and serviced on a strict schedule. This means that by the time a jet is ready for takeoff, it has been thoroughly vetted for safety. Flying is statistically one of the safest modes of travel available. In fact, the odds of being involved in an aviation accident are incredibly low compared to driving a car, where risks multiply with every mile on the road. So when you board a plane, you're stepping into one of the most rigorously tested and monitored environments out there. Now you know how a jet engine works and why it's so safe. If you found this fascinating, consider subscribing for more insights.